Okay, so good morning, everyone, and welcome to the summer term at UIC. This course is a course on differential equations. It's the course that we formally like to call Math 220. I'll be your instructor for this summer. My name is Evangelos Kobotis. My email is evangelo@uic.edu. And my office hours are going to be precisely on this Zoom link. On Mondays and Wednesdays at 11:50. Now, I would like to clarify something here. Since these are Zoom office hours, I will kindly ask you to let me know if you're not going to come exactly at 11:50 or close to 11:50, because usually if I'm going to be waiting for like 10 minutes or so and nobody shows up, I'm going to close my Zoom link. On the other hand, which is usually the case, if I have more than one people, then I will conduct my office hours openly unless one of the students has to talk to me about something of personal nature, not of mathematical nature, in which case I'm going to put everybody else in the waiting room till their turn comes. I will be holding my office hours concurrently with my linear algebra course, so some of you might actually have to listen to some linear algebra till your turn comes to ask questions. But other than that, I will try to, I'm not even putting any limit on how long I'm going to stay. So I want to stay there till I answer all of your questions. That's why I'm saying the office hours are at 11:50. The only thing I want you to remember is that if you plan on coming, let's say at 12:10 or something like that, please send me an email and let me know. Does anybody have any questions so far? Okay, great. Let's proceed now with the course procedures. So the first thing that I would like to state is that attendance is mandatory. I'm writing it with uppercase letters, as if I'm saying that, you know, as if I'm shouting this. Okay, my apologies. I don't want to shout at anyone. But here's the story. This course is synchronous. And as you're going to see, there are going to be quizzes that are going to be incorporated in the lecture. So for that reason, and because I want you to keep track of everything that is going on, and because I want you to be able to ask your questions exactly when they occur, I'm asking you to be present during the lecture. And you know what? There's not a you know, an elegant way of putting this, but it's important that you actually have the intention of attending the lecture. So if your intention is to somehow find a way, find a loophole to bypass the attending the lectures or anything of that nature, I will kindly ask you to just you know, drop the course, because it's not going to work out. I mean, at some point, there's going to be an issue. There's going to be a serious issue, and I don't. I would like to avoid this kind of situations. I mean, it's summertime, and a decision on your side to take a course on differential equations should reflect a certain commitment on the course, on its content, and obviously on the procedures that accompany this course. So I don't think there is any margin for exceptions that may have to do with you know, work-related matters or anything else. In fact, I did receive a couple of emails from people who were telling me that their plan is to attend the course asynchronously, and I told them that this cannot work out. Okay, it's as simple as that. Okay, so it's the beginning of the course, and I think we should all try to get started on the right foot, and I believe that we should be clear about what is required of each one of us. Questions, please, on the attendance. Now, does that mean that you cannot miss any lecture? No, of course not. I do have a minimum requirement of 75% so that your grade is not affected. Okay, so below 75%, you may have one letter grade deducted. And if you fall below 50%, then I'm afraid that will not enable you to have a passing grade for this course. Usually a passing grade for this course is considered to be a C. You know, you might be able to get a D this way, but we're not going to have any of this. So in other words, I'm basically saying that please attend. If at some point you have to miss a lecture or two lectures, I think missing one or two lectures over the course of the summer is not a horrible thing. But please realize this, that this is an intensive course, which means when you miss one lecture, it's the same thing as if you miss two lectures during the semester. So for example, let me put it this way. If, for example, for some reason, maybe a justified reason, somebody misses a week of classes over the summer, you will come back and you will start wondering if you stepped into the right course. That this is how different things are going to look like. Okay, because it's the same thing as if you miss two semesters of, 2 weeks in the regular semester. Okay, so this is why I would like to really set the tone and make sure that everybody is clear on this. Secondly, since we're going to be taking quizzes and exams online, you need to have a camera setup. And again, I'm going to be very, very clear about this. Your camera, and you should, I think our first quiz is going to be maybe on Friday, if Friday actually, can't remember if, I mean, I think last year we had the Friday off or something like that. But in any case, the bottom line is that you should be able to have a camera that shows this. Okay, so I want everyone to test their camera to make sure that you can have this set up. Most of you are scientists and engineers, and it should be quite straightforward for you to be able to set up your camera correctly. So you should be visible, your paper should be visible, and a little bit of your surroundings should be visible. Okay, again, these are prerequisites for you to be able to attend the course. Okay, I don't want on the first quiz or the exam to have to tell you, please conform to the setup that I ask you. So play a little with your camera, see where you have to place it so that this is visible. Okay, is that clear to everyone, please?
I have a question.
Yes, please.
So how exactly is this going to work? So is the exam, it's like, am I going to have to use the camera on my laptop for the exam? Because the camera on my laptop doesn't work, but I do have my phone that I can use.
There has to be a camera that will show me this picture. That's all I care about.
But like, are we going to be on a Zoom meeting? Are we going to be?
Yeah, we're going to be on a Zoom meeting just like now.
Oh, okay.
In fact, on Wednesday morning, I gave you this. On Wednesday morning, I'm going to do a test. I'm going to ask everyone to actually show me their setup so that I don't have to start telling you, you cannot do this, you cannot do that over the exam. And again, to everyone who is telling me that I don't have a camera or anything of that sort, the camera is required for you to be able to take this course. Okay, and taking a quiz or an exam without a camera will simply disqualify you from taking that particular quiz. Okay, so yeah, so like I said, I don't expect anything, but I would like to have a test on Wednesday to make sure that everybody understands what I'm asking of you. Okay? I mean, look, I don't want to be unreasonable, but please understand that there has to be a minimum level of transparency during the quizzes and the exams. I'm not even going to ask you, no, I don't think we will have a test. Yeah, we will do the test on Wednesday. I mean, you know, you said in the chat that you're going to get your camera on Thursday. Obviously, that's a concern. But let's take one thing at a time. You have many questions. I will address everything, but right now let's stick on the camera and make sure that everybody understands what I need from you. Okay. Also, please understand that yes, cameras may malfunction, or you know, you may tell me one morning that my camera doesn't work or something along these lines. I won't be able to help you for that particular morning. Okay, please understand that. These rules are firm. Okay, so does everybody understand this, please? Okay. Okay, so again, I apologize. I have to say I apologize almost in advance to in case that anybody is going to be inconvenienced, but you will see that I'm not requiring much of you. I think that when we say that we have a synchronous course, with the exams and the quizzes online, the two things that I just mentioned about mandatory attendance and the camera being this way is going to be something which is which will be needed. Now, many people are asking me about whether you can submit your homework and your quiz. I'm sorry, the homework you can certainly submit electronically. The quiz and the exams now, that's a different story. If you can use your device so as to specifically show that you don't have any other resources, then I will not prevent you from using them. Okay. But if somehow I cannot see what you're working on, so you need to have this setup. As long as this setup is followed, you're good to go. Meaning you can write on your pad, on your iPad, on your whatever other device you have. Okay, I still need this setup. I still need this setup, and you will see. I will ask you to be. I mean, last summer it's almost comical and unfortunate, I would say. You know, you asked me about screen sharing. All you will need to do is submit it on Gradescope. I'm not calling this screen sharing, so let's not get into funky terminology territory that might, create misunderstandings. Okay. No, it's perfectly fine. It's just that you and I are not going to share any screen during the exam. You will, if you're using your pad in a way that we just described as legitimate, then you will just need to submit your work on Gradescope. That's all. It's as simple as that. Okay. And I was about to say that last year, I had somebody that I will say he was cheating during a quiz, and it was obvious because look, he was looking down at his paper, and then he was raising his eyes, looking at something else off screen, and then writing. And eventually he got penalized for this. Okay, so please understand that you will be expected to conduct yourselves, to not do anything out of the ordinary, start looking at different things. That's why I will kindly ask you, I will implore you, in fact, to not break any of the rules of academic integrity. Certainly one of them is to use any kind of resources during an exam or a quiz. So please don't do that. Please, please, please. Okay, I say it every semester, and every semester I will catch somebody who will think that, I don't know what, that either I'm an idiot or we're above, or they're above the rules, or I don't know, your combination. And then the strange thing is that they start pleading. And usually my response is, I was the one who pleaded with you. I was the one who said, please don't do this. So, Yes, the answer is yes. You can take your exam on your iPad as long as your setup is the correct one, the one shown here. Yes. Okay. and you will see. I'm saying all these things not in an attempt to be harsh or to threaten people or anything like that. I want you to genuinely expunge out of your system any such possibility. Do your job. Yes, you may miss a homework. Yes, you may not do well on a quiz. Okay, so be it. Okay, you may get a B on the course instead of an A. I mean, think about it. It's better to sleep well at night, to not worry about anything, to come to the course, ask your questions, learn what it is that you're learning, rather than being burdened with things such as, oh, you know what, I don't have time for tonight's homework. I will find somebody else, copy my homework from, and so on and so forth, and nobody will know. And unfortunately, this is a recipe for disaster. So, you know what, again, please try to completely disengage from thoughts of this type. And if anybody approaches you and tells you, come on, let's do this, and the old man is not going to know, please, just don't get yourselves involved in any such thing. Okay? So let the object of our work here be to learn. Let our goal be to just learn, to be honest with each other about what we understand, what we don't understand. This way, I will be able to address your questions. This way, you will also have a good idea about what you know and what you don't know. Okay? Any more questions here? How will attendance be taken? Excellent question. So first of all, the system is configured so that you have to log on to Zoom through your name. And I also ask you to be attending, which means that I'm assuming that you're not going to just have your Zoom attending for you and you doing something else in the background. So at some point, I will be asking you a question, and I will be collecting some information that will enable me to tell if you are really attending. Okay, that's how it's going to be done. There's not going to be any use of a Cadly or any other external resource, but through a simple question during the class, as long as you answer it in a timely way, your attendance will be registered. I mean, again, it's the same thing. I'm asking you to attend, and I'm telling you that it's best for the material, for your understanding of the course, and everything else. And again, if your intention is somehow to bypass all those things, to do things your own way, my suggestion is please don't take the course, because we may clash at some point, and I certainly don't. I certainly want to avoid all of these things. Note I'm not going to post any notes. I'm going to post the lecture, the recording. I'm recording everything right now. Okay, so the recordings are going to be indeed posted. Okay. Okay, so why don't we get started with the coursework? Let's discuss the coursework. So I would like everybody to go on Blackboard and to have the syllabus in front of you. Okay, so this way I can reference a few things on the syllabus. So first of all, on page 10, you have your two exams. So what are the two exams? Let's look at the dates. So we will have one midterm exam on July 7th during class, just for an hour. And we will have our final exam on August 4th. Okay, and again, let me emphasize it here that it is a prerequisite for those of you who are attending the course to be able to take the exam. If you have arrangements for extra time, then you will need to take your exam at the DRC. Okay, if you're currently out of town and need time arrangements, you will have to talk to me. Okay, so I will have my office hours today at 11:50, and we will have to discuss this, what has to be done. But if you are in the Chicago area and you usually take your exams with extra time at DRC, this is what is going to happen over the summer. Okay. Now, let's talk about the textbook. So, my lectures are going to be self-contained, and all the material needed in order to follow the course will be included with the lectures. That renders the textbook optional. And there is a textbook that you can see on the syllabus. And please consider that as optional, but it has extra examples. And certainly my exposition of the material here is not going to contradict what is in that textbook. I'm not going to assign problems from the textbook. So the problems are going to be assigned independently, which means that it's perfectly fine if you have another edition. So I personally have a copy of the 9th edition, but as I said, I will hardly ever look at the textbook. Okay. As you're going to see, I'm going to be posting a study guide for the exams, and this will give you a very good idea about how you're expected to do things on the exam, or what the format of answers is going to be. As you're going to see, everything that is going to be asked of you on the exams is going to have its analogs during lecture. So you're not going to be expected to do something on an exam or on a homework assignment, which is completely different from something that was done in class. So in other words, I will try to make sure that there is a highest degree of compatibility between the lectures and the questions on the homework, the quizzes, and the exams. Okay, so that is my promise and my intent for the semester. So the quizzes are going to be taken, I mean, usually they're going to be during the beginning of the day, so around 8 a.m. But allow me to have the possibility of giving you the quizzes later in the session. So as I said, it seems to me that our first quiz is going to be this Friday. Or on Monday. So I will let you know. You don't have to worry about this for the moment being. It's the first day. After we're done with all these formalities, we will talk a little about differential equations, and depending on how far we get into our discussion and what we do on Wednesday, that will be what we're going to have. So there will be one quiz on each class. Okay, so I will, let me tell you how many I think I will give you. I think that I will give you a total of 15 quizzes during the summer. Okay, so why 15 and not a larger number? Well, sometimes there will be a quiz during sometimes we will not have a quiz, possibly right after an exam or something like that. So there are more lectures than 15, but I think it's fair to say that you're going to have 15 quizzes and 15 homework assignments. So 15 quizzes, 15 homework assignments. Okay, that's what you should expect. And yes, I'm going to drop at least one quiz and at least one homework assignment. So again, this means that if you miss your quiz once, or if you miss a homework assignment, then that is not going to affect your grade. Okay. I reserve the right to actually drop more than one, but it's not going to be more than two. Okay, so anybody who might expect that, it might be 3 or something like that, it won't be 3. It will be at least 1 and possibly 2, but not 3. Okay, so it's fair to say at this point, it's fair to work with the assumption that it's going to be just 1 quiz and 1 homework assignment that are going to be dropped. Okay. Homework assignments are going to be assigned on every class, and they're going to be due on the night of the next lecture. What do I mean by this? So Monday's homework will be due on Wednesday at midnight. So this will give you an opportunity to ask any questions that you possibly have on that particular assignment. Wednesday's homework is going to be due on Friday. And Friday's homework is going to be due on Monday night. There was a question as to whether I would be able to assign the homework assignments for the whole week, and I will kindly not be able to do that for the simple reason that in general, I do have a good idea of what I want to cover on each class, but sometimes because of numerous questions or something like that, I might be a little, the schedule might change a little. And for that reason, you have, I won't be able to anticipate all the homework assignments. So the homework assignments will be posted as we go. And in some sense, strongly advise you advising you to actually try to do them at the pace that they're given. Okay. So don't try to do them all over the weekend or the course is going to be intensive. So I think the pace at which the homework assignments are going to be given is going to pretty much allow you, it's going to pretty much keep you in pace with the course. Okay, sorry, the F was actually cut, so I'm going to change page now. But there's not a possibility for me to scroll as I as I write. But let me change page so that everybody can see. So these are the three pieces of coursework. So our exams, our quizzes, and our homework. And if you look at the syllabus, you will realize that the percentages are as follows. The quizzes count for 15%. The syllabus already says that one quiz will be dropped. As I said before, again, allow me to reserve the possibility of dropping more, but that's something to be considered later. And the homework will be 25%. The midterm exam will be 25%. And the final exam will also be 35%. And I have the cutoffs for the grades. And some of you have taken Calculus 3 here at UIC, and most probably know of that rule that there has to be a minimum on the exams. I'm not going to have such a rule in place for the summer. I don't like it, but maybe you like it, that I'm not going to require you to have any specific score on the exam in order to pass the class. Yeah, so in any case, there's nothing to be happy about here. It's just how things are going to be. And again, I reserve the possibility for lowering the cutoffs for the letter grades, but I don't think this is very likely. So I think the cutoffs are going to be observed the way that you see them in the syllabus. Questions? There was a question about how many problems are going to be on the quiz. Somebody asked it. And the answer is pretty simple. The quizzes are going to be quick. We're talking about 10 minutes. I'm going to give you one question. Those of you who are acquainted with the quizzes for Calculus 3, they're going to be very similar to those. And the quizzes are going to be graded out of 2 points pretty much. So 2 points for all the correct work, possibly with some minor numerical errors, 1 point for substantial work, and 0 points for what could be considered as non-substantial work. No, there will not be quizzes during the discussion. So the only quizzes that are going to have are going to be during the lecture. Okay. The homework assignments on the other hand, will be either 3 or 4 problems per time. I think it's going to be 3 problems per time. And again, they're going to be quite relevant to what was done in class. For the exams, as I said, I'm going to post study guides that are going to, whose goal is to steer you in the right direction. Okay, so again, I'm not going to say that the problems are going to be similar or identical, I should say, to the problems on the study guide, but certainly the study guide will be there to steer you in the right direction without any implicit, any inherent understanding that something should have a counterpart in the study guide if it's going to be on the exam. And there will be no possibility for, notes. Somebody once, the people are saying, I mean, I think you might have heard it, oh, do we have to memorize the formulas or things like that? And nobody said anything about memorization. You have to learn the formulas. Okay, so learning is part of our task here and of the process of understanding the material. Okay, so it's as simple as that. And I think those of you who took Calc 3 and went through the challenge of knowing your formulas, it will be pretty straightforward in this course too. It's as simple as that, pretty much. Okay. In general, you're going to find this course very stimulating, fascinating, and enjoyable. Because I think that at this point, by this point, you must have developed a certain amount of maturity with the kind of mathematics you were exposed to in calculus. And you're going to see different ways that what you have seen so far is going to be used in order to pretty much address one of the most important problems and challenges in mathematics, which is to solve a differential equation. I said previously that in general, the quizzes are going to be given in the beginning of the class, but please do not consider that to be a firm rule. So it is possible that you might see your quizzes later during the lecture. Okay, and again, this goes back to what I said before about please do not make plans of taking the quiz and then have your camera attend the lecture for the rest of the hour. So I get this considerations should be, everyone who is taking the course should ask themselves, okay, so what is required of me for this course? And right now I'm telling you that it's required of you to be attending the course. And that's all there is to it. There isn't anymore. Okay. Any more questions here? Yeah, so the grading scale that you can see on the syllabus, yeah, I think depending on what you're meaning by absolute, so you mean that we curve things? No, there's no curve. So when we say that on the exam you got 70%, that means that you pretty much gave 70% correct answers. That's pretty much the way that the homework and the exams are going to be graded on. As I said, it's a little more rough for the quizzes, but pretty much that's how things are going to be. And for the discussions, my assumption is that they're going to be on Zoom, but you will be receiving emails from your announcements from your TAs. Yeah, I will try to post homework solutions. The homework solutions will be actually selected solutions from submitted solutions. So, but yes, you're going to get some you're going to get an answer and solution key for the quizzes and the homework. Okay.
So I have a question regarding the exams. So last semester in Calc 3, you did this thing where if we got a 95% or higher on the final exam, you would give us an A in the course. Is that going to be the same for this class? Or?
There's no such announcement at this point.
Okay.
Okay. So I do want everyone to do the coursework in its entirety. Usually this is something that I'm considering much later in the semester, depending on the particulars of the semester. And that's why I'm not saying no, but I'm certainly not saying that this is something that you should count on. Okay, so like I said, please try to do the coursework in its entirety.
I also have one question too. How heavily influenced will the lecture be to Calculus 3? Because I personally haven't taken Calculus 3 in a while, and so I just want to know if I'm expected to like refer back to previous notes, and or if we're just going to go over that a little bit more before we get into the content, if it's going to be influenced by Calc 3.
Okay, that's a very fair question, but in general, I wouldn't even identify Calc 3 as the main prerequisite. I think it's fair to say that all 3 calculus courses should be considered a prerequisite for this course. I will be more than happy, and I encourage you now, and I'm glad that you asked this, to give you reminders, periodic reminders on everything that you need, whether that is differentiation, integration, or elements of Calc 3. But in some sense, it is both formally and essentially important that you remember a few things, and let me identify them. How to differentiate and what derivative is. How to integrate and what the integral is. Partial derivatives, we're going to be using partial derivatives. And that's pretty much it. Okay, so you will see that we will not have anything of the fancier things that we saw in Calc 3, meaning double integrals or triple integrals. We will not use those for the simple reason that most of our work will be in one variable. You will see that there will be 2 places where we will be using partial derivatives. That will be when we do exact differential equations, where their solution is very reminiscent. I mean, it's pretty much the same thing as finding the potential of a conservative vector field. And the last part of the course, when we study partial differential equations. And there we will have, a very simple partial differentiation. Other than that, I should say that the majority of the methods that we're going to use hinge on Calc 1 and Calc 2 rather than Calc 3. Okay, so the more esoteric parts, if you will, the parts that, you know, you might not have remembered from Calc 3 are not going to be of great use. But certainly, you know, at this point, it is assumed that you're comfortable with differentiation and integration. Okay. Any more questions, please?
Yeah, so how many hours of work do you think we'd have to give in every single day?
That's an excellent question. And I think I have tried to address it on the syllabus. I know that, you know, I mean, I'm not expecting that you're going to read the syllabus cover to cover, but I believe that my estimate, and I'm trying to find it as we speak so that I don't contradict what I have on the syllabus, but I want to say 15 hours per week. That's, I think, a fair estimate for, and as I told you, I'm trying to find where I have it. I think I have it somewhere on the syllabus, but somebody who remembers their calculus courses well, I think that 15 hours of work on the top of what we're doing here should be sufficient. Okay, this might vary from person to person, but I think this is the average work that you should be. So, and why don't we get a little more in detail into what you should expect to do and how to best prepare for this course. So, so go over the material of the lecture. Unlike Calc 3, where you usually had one monolithic concept that basically the whole lecture was revolving around it, you will see that in many cases, we will have a little more detailed and extensive theory to give here. And that's why it will be important to, if I were you, what I would do is I would try to summarize, create a document where I summarize all the theoretical points that we go over in this course. I think in the long run, this will work very, very nicely for anybody who tries to do this. Secondly, redo all the examples. So when I'm suggesting something like that, what I mean is that you should try to actually look at the problem, at the statement of the problem, hide the solution, and try to do it yourselves, and try to see if what you're doing is making sense or not. And then if it makes sense, fine, complete your solution. If it doesn't, try to see if you can answer the question yourselves as to what is going on in that particular case, or ask me during class, preferably. I prefer that you ask all of your questions during class exactly when they occur. That's my strong suggestion. And anybody who thinks that, you know, oh, I'm interrupting the lecture or anything like that, please understand that you're most probably doing everybody a big favor. Because if you have a question, there will be 10, 20 more people that have the same question, possibly more. Okay, so I strongly encourage you to ask all of your questions when they occur. Otherwise, you can ask me during my office hours. Okay, so redo all the examples from class. And once you're done with these two things, then do the homework. Don't try to do the homework before you do the other two things. Okay, it's simply going to complicate things for you, because you will try to do the homework, you will realize that you don't remember everything from the lecture, then you will have to go back to the lecture, try to somehow remember what we did back then. You might half learn it or half understand it, and then go back to the homework, try to finish the homework. I mean, it's going to be a little messy. Okay, so I think this is the best workflow that will guarantee that not only will you understand the material, but you will do well on your homework assignments, on your exams, and most importantly, that you will understand the material that is being discussed in this course. Is there another question, please?
Yeah, so how long should we be spending on the homeworks before we seek help?
That's an excellent question. I think, so I said that there will be 3 problems, right? So if, for example, after having done these 2 things, you see that you cannot even get started, then I think I would say, 10-15 minutes. And but in most cases, you're going to see that the homework assignments are going to be so close to what we're going to be doing in class that this will not usually be the case. But when it is the case, this is why I have structured the homework assignments to be due on the night of the next lecture, so that you have the possibility of asking your questions. And this is why it is relevant. It is important for you to try to follow what is going on in class and ask your questions as we do our examples during class. Next question, please.
So I'm curious about when everything is gonna be ready on Blackboard, because when I'm looking at Blackboard, I only see the things.
Everything that you need today is ready on Blackboard. So I have even posted a homework that will acquaint you with grade scope. I'm going to talk about this in a moment.
All I see on Blackboard is syllabus and Zoom links. I don't see anything else.
What else do you think you should be there at this point?
I mean, homework. You said that you were going to post a homework to get us ready. I don't see any of that.
It's syllabus, announcements, Zoom links, and then there is a homework link. You may want to refresh your page, but there is a homework that has already been posted. Okay. And there are a few more things that will appear on the on Blackboard, and let me be specific about those things. So you will see very soon the exam guides, maybe by next week, and you will also see solutions for homework and quizzes. These are the things that you're going to see on Blackboard. Okay.
Okay, I can see the homework. When I opened before class, it wasn't there. So
It's okay. So, but I'm glad that you brought it up, because let's talk about the homework. So the first homework is not really a math homework. I'm just asking you to test grade scope. And in grade scope, the important thing is to assign the answers to the questions. Those of you who have taken Calc 3, this is going to be a breeze. For those of you who have not taken any courses here at UIC before, have not used GradeScope, you will just need to watch a couple of videos to see how GradeScope works. And again, the important thing is not only to upload your document, but also to assign the answers to the specific questions. For this particular homework, where I'm pretty much asking you to repeat what the procedures for this class are, there's just one question, and you will just be assigning your whole document to that question. Now, for the homework assignments and for the exams, there will be different questions, and you will have to assign your multiple answers to multiple questions. Now, if you already have an account with GradeScope, you should be able to see the course already. If not, then you should have received an email. And please use your UIC email. So for example, if you are from another school and you routinely use some other email, you will need to use your UIC email, the UIC email that was created when you signed up for this course, in order to gain access to GradeScope. So I would like you to, this assignment is not going to count for any kind of credit, so it's highly optional, but please do it so that you go over once more the procedures for this course, and please post it by Wednesday night. Are there any more questions, please? And I think there was one more question that I skipped as, so there was a question about any prep videos for previous material. I'm afraid the answer is no for this one. I do currently putting all of my Calc 3 material on YouTube. But as I said before, the emphasis for the tools that we're going to need for this course should be on Calc 1 and Calc 2. And for that, I don't have any videos or anything of that type. Again, the only thing that you should be ensuring that you understand well is integration, differentiation, and integration. And I think there are plenty of videos that you can look up by yourselves online, or just go over your textbook. Any more questions, please? Okay, then. So usually at this point, I'm going to be giving you a break or a little before 9 o'clock. I'm not going to give a break today. I'm just going to go over a couple of things regarding differential equations. And then we're going to just continue on Wednesday. So let's talk a little about the object of this course and why it's interesting, why it's important, and what the plan for the semester is. So first of all, each one of you here has seen differential equations before. You might say, no, we haven't. Yes, you have. And the simplest differential equation that you have seen is something like this. So when you had a problem of this type, meaning an indefinite integral, then this problem is equivalent to asking the derivative of what function is x over x squared plus 1. So in other words, this question or the question, find y such that y prime is equal to x over x squared plus 1 are the same thing. And in the second problem, what we have is an equation where the unknown object is a function. And in that equation, we have a relation between known functions, the unknown function, and its derivative. So a differential equation is an equation, and here I should say an ordinary differential equation. I'm going to say why I call it ordinary in a second. So an ordinary differential equation is an equation involving an unknown function, a presumably unknown function. I mean, there are cases in which we say we write down a differential equation and it's satisfied by such and such function. So in this case, we say an unknown function, its derivatives, and other known quantities. And let me give you some examples of such differential equations that are going to appear in this course. So you will see things like this: y double prime plus 3y prime plus y is equal to cosine t. So here our function is supposed to be a function of the variable t. And you see that you have a relation between the second derivative, the first derivative, the function itself, and the known quantity cosine t. So here the idea would be, can you find a function, can you figure out a function y of t that satisfies such an equation? Or it is very common to actually use the Leibniz notation. So dy over dx, so the derivative of y with respect to x is equal to 3y. This is another differential equation. And you will see that not too often, but in a few instances in this course, we will also be writing things like this. So 3x squared plus 1 dx plus y dy is equal to 0. Here, the assumption is that when you see something like that written like this, then this is the same thing as 3x squared plus 1 plus y times dy over dx being equal to 0. So in other words, it is more like the form that we just saw. And you have here dy over dx. So this is when you see these expressions that we usually call them differentials. So these are differentials. We will avoid mostly this notation, but it's something that you may encounter, and it's something that we encounter in applications. So this is what an ordinary differential equation is, and the object or the object that we try to find to determine in a differential equation is a function of one variable. So here I should say that this is a function of one variable. I will kindly ask you to avoid to write on the whiteboard while I'm writing, okay? Thank you. Now, you could have the exact same situation with functions of several variables. So we could have had an equation involving a function of several variables along with its partial derivatives. And in that case, we talk about a partial differential equation. So we should say here that partial differential equations partial differential equation involve unknown functions of several variables. Can everybody see what I'm writing?
I can see that. I think she has a problem in her device.
Yeah, I'm sorry about this. So a function of several variables and its partial derivatives. So one classical partial differential equation is the so-called Laplace equation in two variables, for example, that looks like this. So your unknown function here is u. Those of you who took Calc 3 with me may have seen how we took this partial differential equation and we expressed it using polar coordinates. Okay, so this semester we're actually going to, in the very end of the semester, solve some equations of this type. Okay? But mainly this course is on ordinary differential equations and not on partial differential equations. The other thing that I should note here is that in most important cases, especially the cases that come from applications, differential equations are accompanied by conditions. So very often, differential equations are accompanied by conditions. So maybe the best example that we could give, maybe the simplest example that we could give is, let's say you have a differential equation that looks like this: y prime plus 3y, excuse me, is equal to x squared. And then we're also saying that y of 0 is equal to 1. So here, this is usually referred to as an initial condition. Okay, so we call it initial because supposedly we want to identify the function at 0. Of course, you could have had any other number instead. And sometimes the equation along with such an initial condition is going to be called an initial value problem. When you go to partial differential equation, you usually have boundary value problems that are related to the values that the function assumes on the boundary of the domain where they are defined. We're going to say more of these things regarding partial differential equations around the end of the course. Here, the one thing that I would like to emphasize about initial value problems is that the number of conditions should be the degree of the equation, meaning the order of the equation, which is the degree of the highest derivative that you see. So for example, if I had an equation of this type, exactly because I have a second derivative, I would call this a second order equation. And I would need two conditions. So this would be your typical initial value problem in the case of an equation of order 2. So here we would say that we have order 1 because of the presence of the first derivative. And here we would say that we have order 2. Okay, and that's it. So you will see that in most cases, there will be a routine process from going, when going from a differential equation to, from the solution of a differential equation to the solution of an initial value problem. And that's why the emphasis will be on solving the initial value problem, but there will be a couple of instances where the initial value problem will actually be central in the way that we solve the differential equation. And now I would like to ask the important question for those of us who do not use mathematics for mathematics. Because yes, one can easily have mathematical courses where our only concern is to answer all sorts of questions that have to do with numbers, shapes, functions, and whatnot. But most of you are considering mathematics as a tool. So the question is, why do you have to learn about differential equations? And the answer is the following. So in most problems that we encounter in that are using mathematics in applications, and those applications could be engineering, physics, and so on, we're trying to find a law that describes how things happen. And usually that law involves a relation between some unknown function and its rate of change, possibly of higher order, meaning not just the rate of change, but the rate of change, meaning second derivatives. So for example, if you look at the simplest thing, or what started it all. So if you try to trace things back to their origins and see how mathematics became such an important tool in sciences, why calculus, for example, became the common language of sciences, you will realize that it all started with Newton and the revolutionary methods that physicists of the 16th century and 17th century used in order to understand the world that surrounded them. And you will see, for example, that one of Newton's laws says that the force is proportional to the acceleration. The moment you say acceleration, you imply that you want to study the motion of the object that you have in front of you. And its motion is really an unknown quantity. And what you're doing is you start with some information regarding the rate of change of that unknown quantity. In this particular case, you're talking about the second derivative. So you're saying that the force is proportional to the second derivative. That's already a differential equation. And those of you who have studied physics have seen that such differential equations allow you to eventually solve them and come up with the laws of physics that govern how things are happening. So we're going to also, during our course, we're going to see some explicit examples of such problems. Some of them will be directly linked to particular theories, and some of them will be more general problems that can be used with the usual method of mathematical modeling, where you take a concrete situation and you try to express it using numbers. Okay, so in some sense, the theory of differential equations represents the link between calculus and concrete applications of mathematics. And this is why we're going to study it in such a detailed way. Are there any questions, please? So before we go, I would like to just show you how I'm going to be taking attendance. Obviously, some of you already know that. And today, the reason I'm going to take attendance is, today is okay if you miss this course, but I want to really get in touch with the people that have registered for the course and did miss the lecture. And so in the chat, please write the keyword lecture. Okay, please write the keyword lecture to make sure that you're here and you're attending. And I wish you a nice rest of your day. And as I said, my office hours are at 11:50 in case you have any questions to ask on procedures or on special difficulties or arrangements that you would like to discuss. And that's all for today. I will see you on Wednesday, and we're going to get started with our I cannot answer that question. Okay.
I have one final question. When are you going to start your office hours?
Today.
Okay.
I just said that anybody who is going to come to the anybody can come at 11:50 and ask their questions. The link is going to be the same. Okay. And that's all for today.
Okay, well, have a great day, Professor.
You too. Thank you so much.
Bye.